Welcome to wpi.edu/listen, your go-to audio news and podcasts for all things Worcester Polytechnic Institute. After you've listened in, check out our other episodes and dive deep into the exciting news stories shaping the WPI community. Thursday, August 7th, 2025. When driving at night, mind the thermostat. Research from Shichao Liu's lab shows temperatures in vehicles impact driver performance. To determine the ultimate driving environment, WPI researcher Shichao Liu has put drivers to the test in some interesting ways. Liu, an assistant professor in the Department of Civil, Environmental, and Architectural Engineering, has measured the performance of study participants in a driving simulator while outfitting them in caps to image brain activity and exposing them to varying light levels, heat, cold, and even stinky t-shirts. Now Liu's lab has published new research showing that when it comes to driving performance at night, the temperature inside a vehicle matters. Study participants who drove in a simulator were less comfortable, sweatier, and more mentally stressed as temperatures rose. They also used the simulator's accelerator more and drove in a way that would increase the vehicle's pitch and roll, meaning there would be more car body movement that could make rides feel rougher. As the temperature inside the simulator went up, participants drove less steadily and with more variation in their speed, Liu says. This has implications for air conditioning operation in vehicles, vehicle design, and of course, safety. The group's research, which focused on both temperature and lighting, was published in the journal Building and Environment. In addition to Liu, authors were Chao Wang, Ph.D., class of 2024, a postdoctoral researcher at Harvard Medical School and McLean Hospital; John Elson, a research engineer at Ford Motor Company; and Yingzi Lin, a professor at Northeastern University. The research was supported by WPI and the Ford University Research Program. Both temperature and lighting play a role in what people experience in vehicles, Liu says, and those experiences have implications for a driver's ability to safely and effectively manage a vehicle, make decisions, and respond quickly to different scenarios. Concentration, cognitive skills, memory, and reaction times are all impacted by temperature and thermal comfort. Light generally can affect alertness, sleep-wake cycles, and mood. When the temperatures are very hot or very cold, drivers can feel uncomfortable and annoyed, which impacts their driving, Liu says. In addition, studies have shown that during hot summers, drivers drive more aggressively. Thermal comfort and optimal lighting conditions also have implications for how vehicles of the future are designed, according to Liu. Commuters using self-driving cars might need temperatures and lighting that allow them to work while traveling. Electric vehicles may need to be designed with sufficient battery power to provide air conditioning for drivers traveling long distances in hot weather. To test multiple temperature and lighting scenarios under controlled conditions, the researchers built a simulator that replicated the experience of driving a typical sedan. First constructed in Cavan Hall and later moved to Unity Hall, the simulator was equipped with screens and a projection system to display front, left, and right window views from a video game that depicts driving at night. A steering wheel vibrated to provide a realistic driving sensation, and an audio system generated road noise. Foot pedals simulated brake and accelerator pedals. Wang, who was a graduate student in Liu's lab at the time, even hit the road for the study. He loaded his car with sensors and drove through Worcester to measure nighttime light, so researchers could replicate realistic conditions in the simulator. After screening applicants for a type of motion sickness that occurs in simulators, the researchers randomly assigned 72 participants to 3 groups that drove while the cabin's temperature was set at 18, 23, or 28 degrees Celsius, approximately 64, 73, or 82 degrees Fahrenheit. All participants drove under 4 different ambient lighting conditions and, in a test of their mental performance, responded to numbers that flashed on a screen while they drove. The simulator collected information on vehicle position, motion, acceleration, steering wheel movement, and gas pedal usage, and study participants completed questionnaires about their experiences. Liu says that while the simulator provided valuable data, real-world driving may involve additional factors. The results offered some clear answers about light. Participants noticed changes in lighting, but the lighting changes did not affect driving performance. Liu says that finding contradicted some expectations about lighting's role in comfort or alertness. In contrast, temperatures mattered. Higher temperatures impaired driver accuracy, and participants reported more mental strain, more sweating, and more sleepiness. Overall, participants preferred the middle driving temperature of 23 degrees Celsius, 73 degrees Fahrenheit. Liu, whose research focuses on the design of healthy and sustainable indoor environments, says the next step in his lab's research will be to analyze brain data collected from participants in the driving simulator. We're interested in how brain signals and brain oxygen levels change under different temperatures and lighting conditions, he says. It's possible that we may find subtle differences in brain activity that will go beyond what driving behavior can tell us.